Hey guys, it's Hal, and welcome back to ChamAcademy. So today, we'll be looking at equations and problems involving different types of energies. So, sorry, I'm really sick today. So,
Alright, let's start off. James, who has a mass of 63.5 kilograms, is running through the 6 with his bros. If he has a constant velocity of 10 meters per second, how much kinetic energy does he have? We know the equation for kinetic energy is EK is equal to mv squared over 2. If we plug in the values, it's 63.5 times 10 meter per second squared over 2. And if we use our trusty calculator, we get 317.5 joules. Let's do the second question. Thomas throws a basketball straight down the roof of ChamAcademy, which is 20 meters tall. The ball has a mass of 0.4 kilograms. What is the gravitational potential energy of the basketball? If we know the equation, Eg is equal to mgh, let's plug in the values. 0.4 times 9.8 times 20, let's write that down, times 20 is equal to 78.4 joules. Alright, third question. Isaac, who has a mass of 50.2 kilograms, is standing on top of a platform that's 3 meters above the ground. If Joey pushes Isaac off the platform, what will Isaac's velocity be right before impact? We know that the kinetic energy at the initial plus the gravitational potential at the initial total energy is also equal to the kinetic energy at final plus the gravitational potential at final. But we know that there's no kinetic energy at initial and no gravitational potential at the final. So let's plug in the values. mgh is equal to the kinetic energy at the final. We know EK is 1/2 mv squared, so let's multiply everything by 2. 2 mgh is equal to mv squared. Now let's rearrange to solve for v. So v is equal to root 2 mgh over m. Now we can cancel out the m's, they're not important. Let's get rid of m. So it's root 2gh. Now let's plug in the values. Root 2, 9.8, which is g, and the height, which is 3, so let's put that in, times 3. And if we use our trusty calculator, what we get is 7.67 meters per second. Alright, we're going fast. Next question. There's a spring elastic constant equals 3, elastic energy equals 0.5 joules, horizontal compression equals question mark. EE is equal to half kx squared. Let's rearrange for x. So x is equal to root 2 EE, which is elastic energy, over k. Now let's plug in our values. So x is equal to root 2 elastic energy, is equal to 0.5 joules. Let's put that in. 0.5 joules over k, which is elastic constant, equals 3. Now let's plug this into our trusty calculator. What we get is 0.58 meters, which is, of course, 0.6 meters with sig figs. Next question. Now homicidal, Isaac runs at the top of a platform with a pot filled with 1 kilogram of hot water, which he boiled from 0 degrees Celsius to 80 degrees Celsius to throw on Joey. How much heat energy would need to transfer the water? Remember, the specific heat capacity of water is 4.18 joules per kilogram times Celsius. Now let's look at the equation for heat capacity. Q is equal to mc delta T. Let's plug in our values. Is equal to 1 times 4.8 times 80. Now let's just plug that in. What we get is 334.4 joules. With sig figs, of course, that is equal to 300 joules. Alright, next question. 2 electrons. We're given the charge of the electrons. We are given the electric potential energy. Now we have to find the radius. We're also given the K constant. Now we know the equation for electric energy is KQ1 times Q2 over R. What we have to do is rearrange to solve for R. So let's do that right now. R is equal to KQ1 times Q2 over electric energy. Now let's plug in our values. So we have K, 9 times 10 to the 9, times the charge of an electron, because we know that, squared, because remember, it's multiplied by itself. So we gotta also put squared, and then over 5.4 times 10 to the negative 4, because that's what we are given. Now, what we have is, for an answer, 4.28 times 10 to the negative 29, which is also 4 times 10 to the negative 29, given sig figs meters. Alright, next question. Sorry about that.
so Joey decides to end this once for all. He decides to use an exothermic reaction to release enough energy to burn Isaac. He uses a chemical reaction. P4 plus 5O2 yields 2P2O. how much energy in kilojoules will Joy release? By the way, Joy is really bad at chemistry, so he doesn't know if this will actually work. So let's start by drawing out all the structures of the reactants and products. So we have P4 plus 5O2 yields P2O, and that's 2 moles of that. So let's draw double bonds on O. So we have to find enthalpy, which is the total amount of internal energy within a molecule. So let's draw delta HR, which is enthalpy, is equal to sigma, or the sum of mole times enthalpy of reactants, minus the sigma, or sum of mole times the enthalpy of products. Let's write products. So we know that the sum of the reactants has to be P4 plus O2. So by the time 1 mole times 6 bonds of P to P, phosphorus to phosphorus, we write down, we know it's 209, plus 5 times 1 mole, 5 moles times 1 bond of oxygen to oxygen, which we know from our chart is that digit right there. So minus, and we have 2 moles of 4 bonds times 460. Those are the single bonds. Those are double bonds, plus 2 times 377, which are the single bonds. And by using math and just using our trusty calculator, we get 3744. That's for the reactants, and 5188 for the products. To calculate the total enthalpy, we get negative 1444 kilojoules, which means that we get, it's an exothermic reaction, and we get 1,444 kilojoules created.